Imagine for a moment that you are standing in front of a piece of uranium. What would cross your mind? Perhaps the fear of an imminent explosion, or maybe an irresistible curiosity about what would happen if you actually touched it. The truth is, when it comes to uranium, there is much more than popular myths would have us believe. This heavy metal, which was once the key to one of the most devastating moments in history, is also an inexhaustible source of knowledge for science. We are often told to keep our distance from anything radioactive, and with good reason. But what if I told you that touching uranium is not exactly what you imagine? Sure, there are risks, and some of them are deadly. However, there are also a series of surprising revelations that only those who venture beyond the obvious can discover. On this journey, you will not only understand what really happens when someone touches uranium, but you will also learn valuable lessons that can be applied in other areas of life. After all, knowing something so powerful can change the way you see the world. Shall we explore together? It's curious how an element like uranium, often associated with destruction and power, can spark so much fascination. Just imagine, a metal so common in the Earth's crust, and at the same time, so full of mysteries. It's no wonder that science is dedicated to deeply studying its properties, not only because of its impact on our lives, but also because of its potential to reveal secrets of the universe. When someone encounters uranium, the immediate thought might be of something dangerous, but there's an almost magnetic attraction in wanting to know more about what lies behind such a powerful name. Uranium, besides being one of the heaviest elements we know, is present in significant quantities on Earth, which in itself is a reason to pique curiosity. Have you ever wondered how something that seems so distant from our daily lives can actually be so ubiquitous? From the depths of mines to the most advanced research centers, uranium is present. It becomes a symbol of the duality that science often faces, the potential to create and to destroy. This duality is what makes it so intriguing, and it's why it's worth understanding its nuances. Uranium, occupying the 92nd position on the periodic table, is one of those elements that never go unnoticed. It is more abundant than silver, which might seem surprising given its impact on the history of science and humanity. With its 28 different forms, called isotopes, uranium stands out not just for its mass, but for its ability to transform, releasing energy in processes that go far beyond our everyday comprehension. Among its natural isotopes, U-234, U-235, and U-238 have particularly intriguing roles. U-238, for instance, is the most abundant isotope and, curiously, the most stable. Its stability is due to a fascinating phenomenon called half-life, which is a measure of the time it takes for a radioactive element to decay by half. U-235, on the other hand, is the one that sparks the most interest in science due to its unique ability to sustain nuclear chain reactions, something that can be both a blessing and a curse, depending on the context. Science, always curious, seeks to understand how these isotopes can be used safely and effectively. Thinking about daily life, imagine the amount of uranium that has already been extracted and used over the years. From nuclear reactors to weapons, its presence is a constant in the search for new sources of energy and power. This makes us reflect on how a simple atom can carry so much responsibility. However, for those who are not scientists, uranium might seem like something distant, but it's closer than one might imagine, present in minerals that make up the Earth's crust and, therefore, an integral part of our planet. Radioactivity is one of those phenomena that capture the imagination. It's something we cannot see, but we know it's there, influencing the world in subtle yet powerful ways. When we think of uranium-238, the most abundant isotope of uranium, we come across a fundamental concept: half-life. With a half-life of 4.5 billion years, U-238 offers us a unique window into understanding the longevity of materials and the passage of time on a scale that defies our daily understanding. It's almost like holding a piece of the universe's history in your hands. Half-life, for those who may not be familiar, is the time it takes for half of a radioactive material to decay, emitting radiation in the process. In the case of uranium-238, this process is incredibly slow, which makes it a valuable tool for dating rocks and studying the Earth's history. Imagine the possibility of taking an ancient rock and, through the uranium contained in it, tracing its origin back billions of years. It's a reminder that science has the power to extend our gaze beyond the present, reaching the confines of the past. And it's this resilience that prepares us to face the practical issues of handling uranium. Knowing that it decays so slowly also gives us an idea of how dangerous it can be over time. But there is still more to discover about what happens when we directly interact with uranium-238, a topic that leads us to explore the immediate consequences of its handling and the impact of radiation on our bodies. After all, what really happens if we touch this mysterious element? Touching uranium, especially the U-238 isotope, might seem like a scary idea, but the reality might surprise you. When it comes to uranium-238, the risk of touching it is relatively low. The radiation it emits is alpha radiation, which has little penetration, incapable of passing through the skin. So if someone touched this metal, they would probably not feel anything immediate. However, the danger increases significantly if the uranium is inhaled or ingested, as in that case, the radioactive particles could directly interact with internal tissues, which is extremely harmful. Understanding the difference between isotopes is crucial here. U-235, for example, is more radioactive and used in nuclear reactors. This isotope emits radiation that can be more penetrating and therefore more dangerous to touch, especially if handled improperly. This information is essential for those working in environments where uranium is present. Science teaches us that caution is always the best strategy when dealing with radioactive materials. Knowledge is our first line of defense against invisible risks. However, what often goes unnoticed is how small amounts of uranium can be present in everyday objects, such as antiques that used uranium compounds in colored glass. Although casual contact with these objects is rarely dangerous, the mere fact of knowing this reminds us of the need to treat uranium with the respect it deserves. Avoiding direct contact and never inhaling uranium particles are basic precautions that anyone can adopt. What's interesting here is to think about how something so powerful and dangerous can seem harmless to the touch. This leads us to reflect on the many paradoxes we find in science and life. But the real danger of uranium lies in its use and manipulation for more complex purposes, especially when we talk about nuclear energy, where the real threat is not just the uranium itself, but the byproducts resulting from its reactions. And it is exactly these byproducts that we must worry about as we explore the applications and dangers associated with uranium. Uranium-235, with its unique ability to absorb neutrons and trigger chain reactions, is at the heart of nuclear reactors and nuclear weapons. When these reactions occur, the result is the release of a colossal amount of energy, a powerful demonstration of what science can achieve. However, this power comes at a cost, and that's where the dangers become evident. What many people may not know is that the real risk of uranium-235 is not just in the initial reaction, but in the byproducts created after fission. The byproducts of nuclear fission are highly radioactive and can emit beta and gamma radiation, which are much more penetrating and dangerous than the alpha particles emitted by uranium-238. This radiation can pass through materials and tissues, causing cellular damage that can lead to serious health problems, including cancer. That's why the handling and storage of nuclear waste are matters of utmost importance and care in the nuclear industry. A practical example of this is the storage in geologically stable repositories, a practice essential for minimizing the risks of radiation leakage. Obviously, the applications of uranium go beyond reactors and bombs. It is also used in the nuclear propulsion of submarines and spacecraft, where the need for long-lasting and reliable energy is crucial. However, science also warns us about the environmental impact of these uses, with groundwater contamination and worker exposure being ever-present issues. This shows how the use of uranium is a balancing act between benefits and risks, where science plays a fundamental role in seeking safer solutions. The complexity of uranium-235 applications and the dangers associated with it lead us to reflect on the responsibility we have when dealing with such a powerful force. It's not just a matter of technology, but also of ethics and environmental responsibility. By understanding the risks, we can move forward more consciously and safely in using this powerful resource. However, we cannot ignore the fact that, despite all the advances, uranium continues to represent a considerable danger, especially concerning its toxicity and radiation risks, which leads us to the next topic. Uranium is an element that carries a dual danger. It is not only radioactive, but also chemically toxic as a heavy metal. When ingested or inhaled, uranium can accumulate in the bones and kidneys, where continuous radiation and chemical toxicity can cause significant damage over time. This lethal combination makes uranium a substance that must be handled with extreme care, both in industrial environments and in more everyday situations where exposure can occur in unexpected ways. Science teaches us that the risk of cancer increases considerably with prolonged exposure to radioactive materials such as uranium. Even in small quantities, the radiation emitted by uranium can alter the DNA of cells, which can lead to the development of malignant tumors. Moreover, uranium's chemical toxicity can cause kidney failure and other serious health problems, especially in workers who handle the material directly without proper protection. It's a reminder that, in science, knowledge is our best defense against invisible dangers. A practical example of where the risk becomes real is in uranium mining areas, where dust-containing uranium particles can be inhaled by workers, exposing them to dangerous levels of radiation and toxicity. In these cases, the use of protective equipment and the implementation of strict safety protocols are essential to minimize the risks. Unfortunately, these measures are not always adequately adopted, resulting in serious health problems for those on the front lines. After everything we've explored about uranium, there is no doubt that knowledge is indeed power. Science has shown us that with great power comes an even greater need for caution and respect. But it has also shown us that curiosity is the engine that drives us to new discoveries. Are you ready to apply this mindset to your daily life? What else can you explore that seemed dangerous at first, but actually hides a vast field of possibilities? Think about it. Now, to continue this journey of knowledge, subscribe to the channel and activate notifications. Let's keep learning and exploring together, because curiosity should never be silenced, and learning should never stop.